Assalamualaikum warahmatullahi wabarakatuh. My name is Azim bin Ahmad. My metric number is AA191548. So now I would like to talk about the introduction of our group project that is for subject control system. So let's begin. For 1.1, that is the advantage and disadvantage of PID controller. Every single teammate will surely have its advantage and disadvantage to its users. This is because all created things will not perfect, just like PID controller. So what are the advantages and disadvantages of the PID controller? So let's take a look. The first one is it only happens on the fault between the desired signal and the control signal. Therefore, we do not need additional measurement of integral conditions, which is one of the biggest advantages in this application. This is because more measurement means more sensors, so it will increase more signal adjustment as well as more maintenance. In turn, more cost is required. In addition, the advantage of PID controller is it is not a heavy hardware, so it can be implemented on cheap hardware as well. For example, the Arduino Uno can run several PID loops very efficiently. Lastly, the PID controller, once designed, then further tuning does not require skilled manpower. However, if not set correctly, the output can produce aggressive gains that can damage the entire system. For the disadvantages, one of the disadvantages of PID controller is the controller are not suitable for non-linear probes in general or in public language. This is because the controller may not guarantee the desired performance for the changing environment or operating point. In addition, in high-class applications such as fighter jets, it only achieves stable performance around fixed operation areas. Last but not least, the disadvantage of PID controller is PID has several weaknesses that can have significant negative effects for most control problems. A large number of negative sentiments about PID stem from poor implementation and not the algorithm itself, but the main disadvantage of PID is that it's a feedback algorithm, so unable to take control action until it sees interference and errors are made. Therefore, the recovery time can be long enough to produce the poor performance. So that's all from me. Thank you.
Okay, Assalamualaikum and good evening. My name is Ahmad Usamah bin Nazar. My metric number AA191939. So today I'm going to present about why implement PID controller. PID controls consists of proportional controls P, integral, I, and derivatives D. In addition to PID, there are also a combination of other controls such as P, PI, and PD. PID controller is the most common control loop feedback controller used in the control system. But what is used for? How does every component P, I, or D in PID controller affect the control systems? Let us discuss it with good reason. PID controllers are widely used because they are very easy to understand and because they are quite effective. One of attractions of PID controllers is that all engineers understand differentiation and integration conceptually so that they can implement control systems even without a deep understanding of control theory. These PID controllers have good capabilities in dealing dealing with various control problems throughout the process industry. Control problems mean that control process have their primary mission to force process variables to reach a set point either slowly or quickly. The mover will also be responsible in implementing the controller correction efforts so that the set point can be reached. With this, the controller will be the most accurate and stable controller. Another reason PID is used is because it can simplify our task. This is due to the automatic control or automatic adjustment available for the PID controller. For example, in controlling water temperature in industry, to maintain a constant water temperature, the operator must install the PID controller to the desired temperature instead of using operator to control the valve manually. By saying that, this can reduce the cost of working for the operator. Application of PID controller. Currently, PID controllers are automatic systems, often used in industrial control applications to regulate temperature, flow, pressure, speed, and other process variables. There are a lot of example application of PID controller in the industry and domestic use. Almost every process control application will benefit from PID control. The controller takes input from the temperature sensor and has the output connected to a control such as a heater or fan. Controllers are usually only one part of a temperature control system, and the entire systems should be analyzed and considered in choosing the right controller. The first example of application of PID controller in industry is temperature control of furnace. Generally, furnaces are used to absorb heating as well as store large amounts of raw materials at large temperatures. It is common for materials to be used to insert large masses, therefore requires inertia in high quantity, and the temperature of the material does not change quite quickly even if there is a large heat. This feature produces a stable PV signal and allows the derivatives period to correct errors effectively without extreme change in FCE or CO. Another application of PID controller in industry is oven temperature monitoring. Continuous ovens are used in many industries. One of the applications is to cure rubber products. Proper temperature handling can ensure complete healing is achieved without compromising the material properties. Usually, the oven will have a heating, healing, and cooling zone, and accurate temperature measurements in each are important. The digital panel meter can be configured as a temperature meter by connecting the temperature sensor to the appropriate meter input. Not just in industry, application of PID controller also used for domestic such as refrigerator. A proportional integral derivative controller (PID controller) is more appropriate to control the inner temperature of the refrigerator and thus gives the best performance for the response to on-off controller. The effectiveness of the PID control system and its ability to maintain the initial temperature of the refrigerator is consistent from conventional controllers. That's all from me. Thank you.
Assalamualaikum. My name is Nadjmi Firdaus bin Rahman, and I am going to present about other type of PID controller. Okay, let's begin. What is a controller? A controller is a mechanism that seeks to minimize the difference between the actual value of a system and the desired value of the system. Controllers are fundamental of control engineering and used in all complex control systems. Now, what is PID controller? PID controller is an instrument used in industrial control application to regulate temperature, flow, pressure, speed, and other process variables. PID controller use a controller feedback mechanism to control process variable, and it is the most accurate and stable controller. Other than PID controller, there are several controllers that exist, such as fuzzy logic controller, FLC. FLC is used where systems are highly nonlinear. FLC is also a good controller because most of the physical or electrical systems are highly nonlinear. An accurate mathematical model is not needed in FLC. It works inputs based on past experience, can handle non-linearities, and can present disturbance in sensitivity greater than the most of other nonlinear controllers. In recent development, FLC have outperformed other controllers in complex, nonlinear, or undefined systems for which a good practical knowledge exists. The important step in fuzzy synthesis procedure is to define the input and output variable based on previous experiences or practical knowledge. This is done accordingly with the expected function of the controller. There are no general rules to select those variables, although typically the variables chosen are the states of the control system, the errors, error variation, and error accumulation.
Assalamualaikum and hi, my name is Syafiq bin Azim and my metric number is AA191405. Alright, in my video I'm gonna present how to do the task given in project for control system. Alright, based on this project, I'm gonna take a part in part 2, which is result and discussion. And based on test activity that has given, we have to develop the assembly model in MATLAB and do all this. Alright, first let's turn on the MATLAB and open the project. I'm already prepared this because it will run out of time. So this is step block and scope, and the transfer function is based on this transfer function that's given, which is here. Okay, by run the assembly, we produce the graph, the output, and click on data expected to check the graph. Alright, this might be late because my laptop. Okay, this is transfer function 1 output, which is forget about that, and let's continue to doing the task below, which is we have to implement PID controller in the system, and we have to reduce the overshoot settling time and reduce the error in the system. using this. Okay, only using this command window we can put value of, first we have to put value of transfer function, which yeah, it is, let's example of a transfer function number 1, 100. Right, this is a transfer function. So right, to implement the PID controller, first we have to key in what is KB equal to 0.5 KI we don't have to put KI and 4 and KB equal to 10 and K equal to PID controller KB 0 for KI and KB. Okay, so what time for our graph is 0, the time increment is 0.1 and 0 and 20 seconds. Right, for the transfer function feedback is this is a closed loop system, so they must have a feedback. Right, we already have F. So K F and 1 because it's a unity closed loop function. So we have to find the value. This will be faster. I'm sorry because of the lagging. Right, this is our step response for transfer function 1 that I have do. This can also be done in transfer function 2 and transfer function 3 and 4. This is because to find the time, setting time, and steady state. Steady state is 2 section. Okay, this is our output from transfer function 1 by implementing PID controller. The overshoot is 0.0551, which is lower and meet the design requirement. The overshoot is 1. Oh, yeah. And same, using the same step that I was using, we will be doing it on the transfer function 1, 2, 3 and 4. But for 3 and 4 we have to implement full PID controller to meet the system design requirement. Alright, yes. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad Aiman Haiqal bin Abdul. My number message is AA191682. For my part, I will explain about conclusion. In the conclusion, one type of action used in PID controller is the proportional control. Proportional control is a form of feedback control. It is the simplest form of continuous control that can be used in closed loop system. P-only control minimizes the fluctuation in the process variable, but it does not always bring the system to the desired set point. It provides a faster response than most other controllers, initially allowing the P-only controller to respond a few seconds faster. However, as the system becomes more complex, the response time difference could accumulate, allowing the P controller to possibly respond even a few minutes faster. Although the P-only controller does offer the advantage of faster response time, it produces the deviation from the set point. This deviation is known as the offset and it is usually not desired in process. The existence of an offset implies that the system could not be maintained at the desired set point at steady state. It is analogous to the systematic error in calibration curve, where there is always a set constant error that prevents the line from crossing the origin. Another type of action used in PID controller is the integral control. Integral control is a second form of feedback control. It is often used because it is able to remove any deviation that may exist. Thus, the system returns to both steady state and its original setting. A negative error will cause the signal to the system to decrease, while a positive error will cause the signal to increase. However, I-only controllers are much slower in their response time than P-only controllers because they are dependent on more parameters. If it is essential to have no offset in the system, then an I-only controller should be used, but it will require a slow response time. Another type of action used in PID controller is the derivative controller. The controller anticipated the process condition by analyzing the change in error. It functions to minimize the change of error, thus keeping the system at consistent setting. The primary benefit of the controllers is to resist change in the system. The most important of these being oscillation. The control output is calculated based on the rate of change of the error with time. The larger the rate of the change in error, the more pronounced the controller response will be. Proportional integral derivative control is a combination of all three types of control methods. It is called PID control. It is most best controller for each transfer function because it combines the advantage of each type of control. This includes a quicker response time because of the P-only control along with the decrease or zero offset from the combined derivative and integral controller. This offset was removed by additionally using the I control. The addition of the control greatly increases the controller response when used in combination because it predicts disturbance to the system by measuring the change in error. Okay, that's all from me. Thank you.